Welcome everybody to our 114th AiM Sports webinar that we've been doing since the pandemic hit in March of 2020. These have been very well received and very powerful, very good for a lot of people. A lot of people going back and rewatching specific topics. You can do some searches on YouTube to find different topics that you may have missed and something that you've run into now and all of a sudden need a little bit more detailed information on. Quite a library of these webinars that we have now up and running. So this is the 40th one we've done of 2021, and looking forward to finishing out the year strong. We've got a pretty good library of guests coming up, so it'll be a good time. This particular webinar, we're going to talk about the SW4 AiM steering wheel, a new product that we have out, a little bit different. We don't normally do a ton of hardware type webinars, but this one is a little bit special. This one does some cool stuff, uses the software in different ways, and we'll probably do even more of that in it. So I wanted to really chat about it and show everybody what this was, and we have our co-worker and fine co-host Robbie Yeoman is joining us here to talk a lot about this. And Robbie is a AiM Sports technician since 2008. A repair technician with a passion for racing electronics. I think he wrote that, but maybe I did. But no, some of the stuff that he's been doing, of course, is the day-to-day support for the products and the phone support on software and all the stuff that we all do here. But he also is creating custom wiring harnesses. A number of the folks in our company are doing that, and that's something we're going to touch on a little bit here because the steering wheel demands a little bit of that, and so we'll talk about that a little bit and give you an idea of what they do. Many time co-host Robbie, thank you for doing this again. I appreciate all your different levels of skill and what you bring to the table here. Thanks for joining me today.
No, I'm happy to be here.
Absolutely. What we're going to talk about in some detail is the new SW4 steering wheel. Some of you may have seen them. It's a picture on the front of our website. It pops up and rotates through with a bunch of other products, but it's kind of a special one. So I'm gonna kind of turn it over to Robbie. I'll run the presentation, Robbie, if you wish, and then as we go through these first few slides, and then we're going to jump out and do some things, and Robbie's going to show us some other special stuff on his computer as well. So, Robbie, tell us a little bit about the SW4 steering wheel.
Well, it's going to come in 4 different sizes. So you can see the 270, the 280, the 320, and the 350. There is small differences between the two outside of the size. The 270 and the 280, they share a 4.3-inch TFT screen, whereas the 320 and the 350, they have a 5-inch TFT screen, so just slightly bigger. But they have the same push buttons, they have the same rotary dials, and the same pinout in design for the software configuration.
Got a question right off the bat from Andy. Most wheels have a place to mount the press to talk. You have to actually bring a special button in order to do that. How does this steering wheel handle that?
So this steering wheel actually has some pass-through buttons, 2 pass-through buttons that they work perfect for push-to-talk activation. So actually, we'll have a little
deeper into that.
Yeah, a deeper section on that.
Perfect. And another good question. What does the 270, 280, the 320, and the 350? What does that relate to? That's the overall width that across, I suppose, right?
Yeah, overall width. So 270 would be roughly 10.6 inches.
Yep, right here.
280 being 11 inches, 320 being 12.5 inches, and the 350 being 13.8.
There you go. And so it's hand placement. The size of. I'm not sure if they measure to the middle of the wheel or the outer edge, but I'm sure it's an industry standard that we're following that same way. Is this the same size as my number 2 wheel? Dean asks. I do not know what the 2. Is there we had the formula?
We had that steering wheel.
Yeah.
Off the top of my head,
I don't remember the sizes of those. I don't remember the sizes of those. Okay, so you've got you talk about, one of the things that we talk about is it's very versatile, and it's give a little bit, maybe it's on the next slide, but give us a little bit more about some of the different things that that is built into this. It's not just a steering wheel.
No, it's a full-blown data logging device. What it does lack compared to our other hardware systems would be the analog channels. It doesn't have native um, analog digital channels. It has one input for RPM, and everything else is modular. So it is compatible with our accessories like Lambda controllers, channel expansions, thermocouple hubs, smarty cams. Um, it's going to make a really simplistic design for the cockpit. And then if you wanted a additional channels, you could option for a channel expansion, or you wanted to run EGT sensors, you can option for a thermocouple hub. And that's all going to come in through one of the CAN buses that we reserve for our expansions.
And it has 3 CAN buses. It has the AiM CAN bus, I suppose, and then the 2 additional, kind of like the units we have now, right?
I always refer to them numerically. So you have AiM 0, which is our proprietary bus. AiM 1 or CAN 1 is going to be the ECU stream tab in the configuration, and then CAN 2 or AiM 2, how I refer to them, is the secondary bus, which in today's configuration we're going to be using all 3 of them.
Perfect. And then the same memory that my fingers my fingers not typing well last night. The with and without paddles, so you can get I found a picture, a drawing, a CAD drawing of the back, and you can see that the paddle shifts and the clutch paddles, replaceable grip frame. So even even this area where it might in a long time get a little bit of wear, or maybe you want to change the colors, that's available to you.
Right, you get heavy wear on the thumb catches and around the outside. And while the grips are very durable, the hardware is incredibly robust. And I mean, we have formula steering wheels like generation 1s that are still in Atlantic cars, and the suede that we used has now seen its age, being out there for 7-10 years. This allows you to replace the grip inserts, and we actually have different colors that you can accessorize your formula steering wheel. I think I would prefer the black, but there is a whole suite of colors that these can come in.
The rotary dials are something that's new to us, and it looks like they're fairly high tech. What are they doing?
The rotary dials are awesome. Instead of a standard potentiometer that has a physical mount to the board, basically it's moving distance. This is a contactless sensor, so there's no direct connection between the wheel or the dial that you're spinning and the board itself. So we have a contactless sense there. Much more reliable when it comes to heavy vibrations, and the technology behind it is fantastic, and we can trim the size. It doesn't have to have prongs that come out and seat to a board.
Yeah, perfect. And what's a good example of where you might use that? I see that it there's calibrations, there's tunings, there's traction control, I suppose. Are those some of the things that you think they would be used for?
Yeah, actually, the possibilities are limitless, and I got a couple
endless,
of them in the configuration today,
Okay.
just to give you an idea of what they could do. But they are CAN operated dials. We can easily send this information out to an ECU to access maps, or access boost control, or access traction control levels,
Gotcha.
or slip factors. For possibilities are wild when it comes to this. You can really program each button, and you can tie them to dial. So you can say that this button functions when the dial is in position 1, and it functions completely differently when it's in position 8. So now you've just increased the amount of buttons that you actually have.
And all of this labeling of the buttons and the dials is all user definable and replaceable, changeable with time as you maybe adjust everything you do. I'm not sure if you have something you're going to talk about that later or not, but I just wanted to mention that.
Yeah, the button inserts are made in-house. We have a list of button inserts that you can pick from, and they pop into the button, and they can be removed and replaced if the configuration changes. So you're not stuck with something that says PTT or fuel. If the configuration has evolved to something else, you can replace the insert. It's not a part of the wheel.
And not only the text is there, but the backing color is RGB, so you can even make them different colors for different things. So kind of interesting. Okay, I'm not sure if you got a chance to look at it, Robbie, but I've got that 22 pin connector on the next slide with some more details. So chat a little bit about what we're looking at here and let me know when you'd like to go to the next slide.
So the pinout is a standard pin configuration that we use for the expansion harness of the MXX hardware system. So like an MXL2 22 pin harness, it has the Autosport connector. It's an AS 61235PN is what we'll be using here. The pinout itself is pretty straightforward. You know, you have power, you have ground, you have your CAN buses. The paddle shifts are actually a pass-through style. So if you notice, there's actually 3 wires for that. So you have a common wire coming in, usually supplied by the shifting actuating device, but sometimes it's just a ground. Most of the time it's a ground. And then we have a dedicated pin for each button contact or each paddle contact. So when you press the right paddle, it sends the ground signal out the right pin. When you press the left paddle, it sends the ground signal out the left pin. So then the transmission control module receives that and says, okay, we want to upshift, we want to downshift. Outside of that, a similar type is the function buttons, but these have dedicated. So this is your push to talk, Andy. This is where we're going to have a signal coming into the hardware system and sit at the edge of the button. And then once we press that button, it will make contact and send it back out. And perfect for radio comms. You can press that button. You can have your radio transmit come in, and then your radio transmit come out. Push the button and activate your push to talk system.
And the other one there would maybe a pit road speed limiter kind of a button. Only hold down while it's on.
A small relay activation would also be another one where you could pull in a ground and pass it through. So when I push this, it activates a relay that's now sending power or signal to some other device on the car.
Anything you wish. Yep. Okay.
And then of course it'll have USB comms, and the function buttons each have their own input, and our CAN 2 bus, or I'm sorry, AiM 0 is on there. So we got AiM 0, CAN 1, and CAN 2.
Here's a little bit more detail of the of that in case anybody wants to download the presentation. I know the link has already been put into the chat box, and those of you that are watching this later on YouTube, down in the description below, if you hit the show more, there'll be a long list of all of the links that have been placed into the chat box that we may mention, or anything else that gets asked about. We'll include all the links into the description box on the YouTube video as well.
Right, so Kyle has a question while we're on the pinout in the connector, that how does the pin coupler work? Is it fragile? Is it hard to wire? The Autosport connectors that we use are not what I would consider fragile. They're a very robust connection, and they're quarter turn pieces. So you can you have the bulkhead connection that can be mounted on the dash or anywhere. We have a coil cord that connects it to the wheel, and it is just a quarter turn to lock, a quarter turn to unlock and remove the wheel altogether. So that brings up some of the packages with the steering wheel. So you can option for a car side harness with your steering wheel. So if you're not comfortable working with the Autosport family line, or you're not tooled to work with the Autosport family line, you can actually purchase a car side harness in addition to the wheel. And then we expose the wires in a flying lead format. So you will have a bulkhead that is harnessed, and on the back side of it, you will have all of the labeled wires, power, ground, CAN, VB, EXT, using our proprietary connectors when it's applicable for expansions, and flying leads for function buttons and paddle shifts.
Yeah, that was one thing that I noticed here. The way that they drew this, it was just a straight cable, but you say it's a coiled cable that allows you to quickly pull the steering wheel off, just set it up even without undoing the connector. Just set the steering wheel up, get out of the car if it's in an open wheel car or a tight production-based car, and then put the steering wheel back on when you get back in. So you could obviously also take off the connector if you wish as well. But, okay. You want to go to the next one? Let's
Yeah.
see. There we go. We just wanted to talk a little bit, just and maybe this will give everybody an idea. You were just talking about those connectors, give you an idea of what it kind of looks like, and Robbie, you can talk about custom harness stuff, but kind of just a quick topic. But leaving these slides in here for those of you that want to download the presentation to get even a better idea, so we can look at it later. So, Robbie, you talk a little bit about custom harnesses.
The custom harnesses give us a little bit more flexibility. We're not using off-the-shelf hardware that is maybe not the appropriate length or needs to be wired up or comes up short. These ones are created based on your need. So if you need to go 6.6 inches, we'll make that happen. The benefit is the reliability and the rugged nature of these bespoke harnesses. They're completely handmade, and you also get an engineering document when it comes to you. So you get a harness. You also have a full document with a pin-to-pin set, so that if there is any damage, you can perform tests at the track. You'll have a full sheet, and we keep them on file here. So if they need to be rebuilt or questions need to be asked about them, the part numbers are all unique, and they can be given to anyone, and we can look up your pin configuration. But it definitely streamlines the process. The size, everything shrinks when you go to this style of custom harness creation.
Okay.
Hop over to the next slide. So this is the engineering document that one would receive, and I like that we put this napkin drawing in here. We get a lot of napkin drawings. Someone has an idea and they just jot it down. They give us rough lengths, and part of the design process is us creating an engineering document that will reflect what we're creating with the harness. And so from napkin to completion is our motto.
Yeah, there you go. There you go. And here's just some kind of cool pictures of what they look like and some of the basics of how you do those. Walk us through a couple of those images. That's kind of cool looking.
So what you can see in the top right picture is a bulkhead connector. This is actually a 22 pin bulkhead. This is what we'd be using for a steering wheel integration. The bulk that you see right behind the knurled edge is the service loops. These are for coming back in if we needed to move things around, and providing a substantial amount of strain relief so that the harness can be tugged or pulled or moved without putting any stress on the pin itself. So that is just one part of creating a harness is building in this type of protection. The bottom picture, that big long rope that you see there, is actually 4 layers of wires twisted in opposite directions, and it provides a tremendous amount of flexibility. You can take it and you can spin it over on itself, and because it's not a straight wire, it allows everything to absorb the load in a uniform manner. It's not going to pull from the outside edge and crunch up on the inside edge, so it gives a lot of flexibility. The 2 pictures on the left are just completed, the bottom on the left is a completed project for thermocouple integration, and the top one is actually what it looks like before you put the bulkhead in on the right. So this is what we work with, and then we turn it into this.
Very cool. Very cool. Okay. Oops, went too far. And then the completion.
Yep, these are once you get it back, you can expect to receive something of this nature that reflects the design that we've both agreed upon, or that AiM and the user have agreed upon. It has the sensor and load testing. We have a Cirrus machine that allows us to do pin-to-pin testing. We can do 500 or 1,000 volt stress test on the hardware itself to make sure that there's no arcing and that we're not going to have any problem with with voltage jumping around. Normally we would send 14 volts, but in this case we can send 1,000 volts to simulate a heavy load that could potentially arc. Helps us get in front of any issues that you would see.
And then you say down to the last bullet, stored documents and configuration just in case. That's an ominous statement there.
We keep them on file so that we can rebuild it, but we send a physical copy with every harness. Now, most people will open the box take out the harness, put it in their car, and want to get out there and use it. And sometimes the document goes away with the box. And that's okay, because we have them on file. We can send them electronically, or we can send you another hard copy so that you have a dedicated manual of the harness that you designed and created.
Perfect. The next one, I think what we have in mind is to jump out of the presentation now and let's focus back in on the SW4. And I'm not going to spend a lot of time showing you every step of the way of how to do these things, but want to give you an idea of the power of the steering wheel. And sometimes the best way to do that is to show the configuration and give you an idea. So what I think we're going to do is I'm going to stop sharing, and Robbie's going to share his screen, and we are going to take a look at some different things he's going to show us. There you go, Robbie. It is showing and you are off and running.
Okay. So I have created a base configuration, and this is how I would approach almost every steering wheel configuration. So if we open this up here, if you wanted to go to new, you could now find the steering wheel and the PDM in the newest versions of software. So if you don't have them, or if you don't have it already, I would suggest doing so. Picking it up, checking it out, and following along. So here we have a basic configuration style, just like our MXL2s and MXPs. We come right into the channels tab, and we have our clutch set up. We have our digital RPM input set up, and we have our paddle shifts, GPS. This is all pretty much the same. If we wanted to change from miles per hour to kilometers per hour, we can do that. So we would essentially set up, if we're using clutch and paddle shifts here, and then correct any units that we'd want to be using. So we're just going to go ahead and scoot right over to the buttons. The buttons are the new addition, and this is where you're going to set up how you want the steering wheel to function, what you want it to do, how you want it to activate. What you can see here, these ones in red are actually our pass-through buttons right here, so they are not CAN operated. We can set up color functions. If I wanted to have them backlit, I could set the color of them and set it to an always true condition. And this would keep the backlight on, so you don't have a dead object here. You know that it's a functioning button. But the inner left and right buttons are all CAN operated buttons, as well as the rotary in the middle. So we can go and set some up. I've already set up a couple of them. So for example, I want to do a fuel pump, and I want it to change color. So I have set this up to a momentary command, and when I press the button, it will illuminate the background color in amber. When I don't press the button, or the button is in the off position, it is a white condition. Now, for this, I've set it up as a momentary button. So as I hold the button, it remains in its on position. When I let go of the button, it is now in its off position. Other option would be toggle, where I can activate the button with a quick press to advance to on, and then deactivate the button with a quick press to advance to off. So it's a software toggle. And the multi-position will allow you to set up different stages. So it can go from off to on, or off to 1 to 2 to 3 to 4 to 5, and then back to off again. And I have a couple examples of that as well. So here the fuel pump setup is just to give me a color so that I know that the button has been pressed, and to illuminate with a background color of white when the button is off. Now this left button 3, I've actually set up as a multi-position. The multi-position allows us to set different labels and values for our buttons as they as they get activated, as well as a map of how we want the buttons to function given the state. And that may sound a little bit it may sound a little bit complicated, but if you read it from the position of the button to what you want it to do, it's not so bad. So in this case, the button is off, and I want to advance it to position 1. When the button is in position 1, I would like to advance it to position 2. And when the button is in position 2, I would like to advance the button to an off position. So you get this circular feel. Every time I hit the button, it advances from off to 1 to 2, then back to off. If I were in position 1, I may want to hard shut down. So I use this timing command, which is a nice feature. It's a push and hold, and you can set the time threshold for activation. So in this case, my long presses all lead to off, and I have a half second. So if I push and hold the button for a half a second, and I'm in position 1, instead of going to position 2, it will actually go to the off position. So we always have a way to, especially if you build 8 or 9 positions, you always have a way to get back to the start if that's what you wanted to do. So here I've set up the
What is the
buttons.
what is the limit on the number of positions you can do there? Have you ever? Is it 9? Oh boy, yeah. Oh boy. Okay, you can get confused pretty quickly. It looks to me. So
Yes.
yeah. Now you've
So
got a
in
bunch
this,
of them. Sorry about that.
that's okay. That's okay. It's good to show. So the LED configuration. This is how you want to be notified what position you're in. So in this case, when the button is in the off position, I want it to show white. When I advance the button to the 1 position, I want it to show blue. And when I advance the button to the 2 position, or the 3 position, I want it to show a green icon. Now I set this up with priority, and what the priority does is, if this is true, then and this is true, this has priority over the previous command. Whereas if this is true, it has the highest priority. So it just stacks the priority so that
Yes.
there's no conflict, because we're really using the same button and the same RGB LED for all of our logic. So the priority is very important, how you write these.
And
In this
very
situation,
similar to the logic we use in every the rest of our alarms and other products. And I always think of it as layering, and the one on the top is the one that you can see. It's much more complex than that, but it always helps me understand it when I think of them as layers.
absolutely. The layering aspect is, in this case, it really doesn't matter, because it's impossible for the button to be in the off position and in the 2 position.
There you go.
So in this case, it's not important, but it's a great habit to get into to
Yeah.
practice what is the most important, or basically cascading these events. So we'll go ahead and exit out of here. So that was a multi-position, and we have a toggle as well. So this is just another option. This one is a little bit different because the long status can actually be used as well. So you have an on, a short, and a long. Or if I turn this off, you just have an on and an off. And this will come into play if you wanted to have maybe just a 3-button position, or you wanted some type of activation where you push and hold, or you have the time to push and hold. Let's see here. So that's a brief overview on the buttons. I'll show you the rotary next, and the rotary has the 8 positions that you would have and the values. So the labels can actually be adjusted. So I can have this as driver, or check, or we'll just use L1 for now. And the value that you want it to represent. The value is very important when you're doing your greater than, less than, equal to commands. But it's more important when it comes down to the CAN output control. This is what we're actually going to be sending out. This is the electronic value of it. So here we have set the different colors for, as I activate the different positions, the rotary wheel will change its RGB LED to let me know that I am actually making those changes. So here is just a standard rotary. These are all pretty straightforward. You just go through and set them up. I normally don't get too complex in this area of the configuration because it hinders the complexity later. And what I mean is, when we cruise into, let's say, status variables, here we have a status variable that I've created, and it has this nested logic that if I hit fuel pump 1 and fuel pump 2, and the rotary, the right rotary is in position 6, then I have now created this truth statement. So if any one of these is not true, then the entire status variable is not true. And we did a great webinar on status variables. So the logic has changed from that webinar to the steering wheel. This is more like the PDM and how most of our math operations are going to be done in the future. So as you can see, the logic can be as complex as you want to make it. So here I've taken my buttons, and I've created a position on the rotary wheel that I also want to activate it. What my intent for this is to pump out. If the sanctioning body wants a bit of fuel, I can actually just turn the rotary dial and press the 2 fuel pump buttons, and now I can pump out some fuel for them. And it's
And
not, I'm not jumpering anything.
exactly. The what I like about what we as a company are doing now with this new logic, while it is more powerful and maybe there is some complexity, to me as a person that is not good at writing, all of these things, I can read this and I can add things, right? Fuel pump is equal to on and, or you could just hit the little button and say if or, and you've got these very simple little toggles to write the logic that is very, very powerful.
So here I've created this status variable. The question that I had initially is, what do I do? Like, now that I have all these buttons and they're functioning in the way that I want, like, how do I get it from the wheel to the car? How can I create this to actually work something on the car mechanically? There's a couple of different ways to go about it. First, you can, in this case, I've actually created a math channel here for steering wheel buttons. And this is called if we just go into here, this is a bit composed. So Roger, I don't know if you want to go through some of the other math channels.
I don't. We've got another couple of videos that have done a little bit of that. I'll try to find the link and we'll send those in. And I think we'll focus on another webinar soon where maybe we'll bring some folks in and we'll go through them again because there are a couple here that have been updated and added.
So for this, we're actually going to use what's called a bit composed math channel. The bit composed math channel will take all of these binary triggers, these 0 or 1s, and they will create a bit field. So I know that bit 1 of this message, or flag channel 1, is my pump out. This actually comes directly from my status variable. So now I have this, it's either true or it's false, a 0 or a 1. And then I have all my other buttons: left button 3, left button 4, left button 5. These are basically the bit values of a CAN output message.
Other things you may have set up as far as button keystrokes and different things.
Exactly. So it's really great for 2 position states. It's either true or false, or on or off.
Rain light on, rain light off, or whatever happens to be.
So you can choose from any of the sources to use this, but you just keep in mind that it is just a flag. It's either true or false, or 0 or 1. So we've used the status variables. We can actually output just the buttons themselves. So if I want to put fuel pump 1 and my pump out status variable, this is now a nice tidy little message. We just enable that and I save it. So I guess, why did I create this bit field management? And it's really to send it out in an elegant way. When we can just fast forward over to the CAN output section. Here, I've decided to take my information on CAN2, the button information from the steering wheel, and I want to send this out to an ECU, or I want to send this out to a control mechanism. I want to send it to a PDM. This is how I'm going to do it. So instead of sending a command for each one, so if I set this to 1 byte and I use a channel for the button, and I say fuel pump button 1, yes, 1 byte. So I have now this value here, this byte 4, which is capable of 256 numbers, and it's really just representing 2, a 0 or a 1. It's not an efficient way to do such a thing. Then all of a sudden we have lots and lots of information that's just related to the buttons themselves. We have to add more CAN IDs. We have to write more receive CAN IDs. If we could do the bit composed, then each bit of this byte will have a unique position. So bit 1 is our pump out. Bit 2 is our left button 2. Bit 3 is our left button 3. And when I build the receive information on the ECU, or the receive information on the PDM, I just set it up as a bit field. When you see this bit go active, then all the logic that I've already programmed into the wheel is true. So activate your power output, activate your input.
Instead of doing each one individually, it's a much more elegant solution and much easier for you to keep track of. You know where to go to tweak this simple bit of information.
Yes, if I wanted to tweak all 8 of my my buttons, I can do it right right here in my math channel section. So we'll go to the here, and I can make the change right here instead of making the change to 8 different channels.
Different spots. Yeah, very nice. Very nice.
So here we have the steering wheel buttons coming out, the rotary middle right and left buttons, and then the fuel pump. So we've outputted all of the buttons on a very small payload. CAN ID can be chosen, and it's very easy to then receive all that information on other electronic devices. We've used PDMs in the past. We've linked this steering wheel with our PDM. We've also used other hardware systems like micro PDM and direct to ECU for boost control activation, and it's worked out wonderfully with this type of bit management. It makes it quite easy. So if you guys are having any struggles with this section of it, we have a couple of webinars where we've actually worked a full receive and transmit configuration, where we took information, we sent it out on the CAN bus, and then we built a receiving protocol for receiving that same information and programming it. So it's an hour long. It's an hour of CAN information. So if this does interest you, I would suggest
checking those out. And I think we've done 3 different videos on different levels of those, and we'll link those in the chat box. And of course, they'll be linked in the description below if you're watching this later on YouTube.
Mm-hmm. So if we work into some of our trigger commands, what you may notice is that all of the buttons are these CAN operated buttons. How do you access the menu? How do you access the menu navigation controls? How do you access the actual memory to get to your top 3 laps, or your histogram chart, or your
stuff everybody is used to on their MXP data loggers, right? The stuff
yes.
they're used to seeing.
Yes, we've now taken all of the buttons and purposed them for something else. So each button here has a unique design that we're no longer have any other buttons for you to actually access.
But you can make them be what you want them to be.
Yes, and we're going to go through that. So here we have a menu control, and what I've done with the menu control is I have linked it to the rotary button, or the rotary dial. So when I turn the left rotary dial to position 6, and I hit left button 5, I can now access the menu. So it is just a quick switch to of the left rotary, and now I can get into my menu. I can get into my my memory. I can advance pages. I can go previous pages, just like the standard 4-button configuration of our other MXX hardware systems. So here is the menu control. You would just activate it by you could do excuse me. You can simulate each one of these buttons, and now we have just given our left button 5. We've given it 2 purposes based on the rotary wheel position. So you can see that we have our menu navigation features, and then the memory button. And I've tied each and every one of them to the right button, or to the left rotary dial, position 6. So all of them are bound to that. Once I turn it to position 6, I have access to my menus.
Perfect.
One thing, how do you get to pages? The pages we have set up as driver 1, driver 2, driver 3, a check page, and I can use the middle rotary dial. And I could say when the middle rotary dial is in position 1, I want to see the driver page. When the middle rotary dial is in position 2, I want to see my secondary driver page. And you can actually set timing commands. So like, how long does it take for when I flip this rotary dial to the next position? How long does it take to actually take the command and take me to this driver page 1? Right now it's set up immediate, but you could put an appropriate number in there.
Delays if you wanted to.
Yeah. So it didn't try to. So if you knew that you had to get to position 5, you could put a time in each one of these, so that you'd turn the dial and it's not trying to switch to each page as it's going through the dial positions. It's got a small timer on there that it has to be true for so long, so that it just takes you right to check page if you wanted to.
Perfect.
And these are of course stacked with priority. So this arrow is a common theme throughout the entire software program. This type of priority setup. So here we've done our trigger commands. We've simulated our menu buttons, and that's all with the rotary dials giving these a unique output. When the rotary dial is in the 1 position, these are my fuel pump out buttons, and these are my 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 PDM activation buttons if I want to turn on the ignition or the ECU or the fuel pump. I'm now commanding these things to actually function. And if I switch the dial, now this is my menu. This is my menu tools to menu navigation. And this is how I access my memory.
In a very normal spot where most people would expect them to be, right? That we have used for so many years in all of our AiM hardware.
Right. And if you could just extrapolate, I mean, I have 8 positions per dial wheel.
There's a lot you can do.
You do, right?
And you're doing them all through CAN, which makes it a very elegant solution as far as wiring and all of that. It makes it very, very clean and nice.
Absolutely, and this is where status variables really, math channels, this bit composed, is really going to streamline a lot of this function because I've now set up, I can imprint my status variables in here. So I create all these status variables with rotary dial and button pressed to become true. Now I can affect different things. I have these 10 buttons. Now I have over 300 buttons with the rotary dials.
Which has been a concern of some people. If you go to status variables, you can see there's still available math channels is 25, and status variables, there is a limited number of things we can do, but what you're doing is stacking multiples under one, right? Which makes this very, very clean and extends out the ability to do all these different things.
Yes.
Very good.
Okay. So here, I guess we can go into the icon management, which is really similar to how we've done it with all of our MXX hardware systems. Here, I've made a pump out icon so that I know that the activation has indeed happened. Then that means that the rotary position is in the position 6, and I'm pushing and holding both fuel pump out buttons at the same time. I'm going to get an icon on the display. And the reason I have option for the icon is because when you're pressing the buttons, the RGB is under your thumb. So on these momentary controls, on these momentary controls where you have to push and hold for activation, it's really important that you have some type of notification that it is functioning.
I'm even going to go so far as to say you could come up with a message that went out across not just an icon,
Absolutely.
right? You could come up and say fuel pumping, or whatever, right? You could have something happen.
Absolutely.
So very cool.
Very cool. Add an alarm. The alarms are pretty
as normal,
user friendly,
right?
yeah, and as normal. Okay, so we have the standard LED sweeper across the top, the 8 RGB LEDs, and you will have 2 LEDs on the steering wheel that are for activating alarms, water temperature control. Now, this may seem like not very many notifications, but I can tell you with the TFT screen, we can present notifications on the TFT screen in such a way that the LEDs aren't going to be as necessary.
I found that with the TFTs that I've been working with people getting preparing their cars, we've been changing the color of the channel value and little messages, and when it gets finally to a point, we're flashing LEDs, and we take over the entire screen and say too hot, right? So LEDs are not nearly as important as they used to be because we can do it in so many different ways.
Right. And I can't tell you on our older systems, MXL Pista, tried and true. I have received numerous phone calls of the bottom left LED just always stays on, and they don't remember what the bottom left LED, or they got it from someone who built it, and there was just no message control there. It required such a mental faculty of the user or the driver to be like, okay, bottom left LED, that was fuel pressure, I think.
battery low, or so I don't know.
Yeah.
To the point of to talk about the difference and such the gains that we have made with what we're doing now. Even when we were running an MXL in our Spec Miata, on the back of my clipboard, which I was keeping track of the race on, I had done a color print of an MXL, had it flipped over, and I had, because things are happening in a hurry and they're stressful, I had my 6 lights lit up, and which one was low voltage, which one was low
Labeled
fuel
with the
level,
little
labeled. So
Croy printer.
when the driver would come on, say the lower right light is on, I could just flip it over real quickly. Okay, that's that's low voltage. That's what you're seeing. Let them know real quickly. It's now it's not nearly that problem where we're able to give feedback so much better to the driver.
Absolutely. Here would be a great condition for adding more status variables. You can just continually add status variables for showing control. So here I have 4 different pages, and while I don't have everything on this page, this is what is important to me while I'm racing. I want to know my oil and fuel pressure, my water temp, and my intake air temp. It's also nice to have the rotary information. So I have the right rotary on the right side, the left rotary on the left side, the middle rotary here. So I know the position of the rotaries without actually having to glance as far down. As the higher up I can keep my eyes, the better.
And a lot of people, I see a lot of people doing it. It's not just driver 1, 2, 3, which you've got them there, but you can rename those, and you can have a paddock, a warm up, a qualifying. What you want to look at for qualifying is maybe is substantially different than you want in a race. It's all about the lap time and maybe predictive lap timing and some basic info. And in the race, maybe you want water temperature and some other things with the drafting or whatever it happens to be. So build these and think these through, and have things that are important to you that are easily changed and tweaked and be shown to you.
Absolutely. And the status variables can help navigate the screen. So if you have,
Exactly.
if you're white knuckled, you can create a status variable that's, if we wanted to manage like water temperature. So we'll do water temp high. We can set this up as a momentary command, and we can say that if my water temperature here, ECT, is greater than 235, this is a true statement. Given water temperature greater than 235, and it seems pretty straightforward and simple that it's how you would build an alarm. The reason why I would build a status variable is because I can now come into my trigger command, and I can say, okay, if my go-to page number, if my status variable is true,
water temp high,
then I want to show that this is actually true. So we'll go to on. Now it will automatically direct me to a new page. So given an event that something I'm not looking at, it will take me directly to the page that has had the problem. There's no dial that I have to move, and I can take this and put it in a high priority.
Absolutely. So you can have these mechanical problem things always bubble up and become very, very visible to the driver. You were in a page a minute ago, maybe it was the status variables. One thing we did not chat about, and I just wanted to, we got about 10 minutes left. We have the ability to record when these things are yes, no, active or not, right? Yeah, and actually bring these into the data, which I think is a added valuable step. So talk a little bit about that. Record values up above in the middle, right?
Absolutely. The aspect for recording this, it's substantial. We had a lot of requests, like we built all of these alarms, and it's really important to know not only that your oil pressure light turned on and maybe the driver didn't see it, but for how long it was under that condition. Where at in the track that condition happened? Is it something that that is due to the nature of the track? It's a high-speed bank turn, and I now have an oil pressure problem, but only in turn 11. It will mark your data for you because we have built the status variable to be true given the conditions that we want. And now we can record that information in the data. So I know how far I went on less than 10 psi of oil pressure, or I know how many times my fuel pressure was below my target value.
Yeah, very simple statement in a channel report saying how long was my pump out, or water temp high, depending on which one, whatever you choose, and get a number of seconds per lap, and then and location. So yeah, I agree. To me, are we going to record every one of these? Maybe not, but we're going to pick the ones that are really important to us. It's just data. We've got a lot of memory, and we can do some things. So recording these is a huge added value.
Absolutely. Some are doers, things that I just need to work, or I need to send out information, and then some are important, and I would like to record them and have the memory control for them. Now, I could write all of my alarms as status variables, and I could come into alarms, and I can simply point them at the status variable. So I've already written the logic. I don't need to write it twice. I can say, okay, now if this status variable is true, then I need to do something on the display so that I have a notification. So this is a perfect example for our LED control. It's a perfect example for the display
switch to a page, or change the color of the all the different things we can do.
So if I wanted to turn my water temperature green or red or yellow, I personally prefer yellow. I don't know what your thoughts are, but the yellow for me is the best contrast on a dark display.
On the dark display, I love it that it goes to yellow and we can kind of see it, and then the next step up, even when it changes away from yellow, it goes to the orange or red. It catches your eye as well.
And I'll usually stack maybe a couple of them. I'll do a warning that just augments the display measure. So the physical value is white. I'm looking at 234 degrees. The second it gets to 235, it'll turn yellow. And then I will stack another command that says, okay, well, if it goes to 240 degrees, then I also want you to flash all of the LEDs at me, and as well as keep this still yellow. So it's almost like a progression. Maybe I want to push it. Maybe if those LEDs
your choice at that point. Recently, just before the national championships in sports car racing, I'll bet you I helped with probably 7 or 8 cars that they wanted to tweak their TFT displays where they got that color change, so they did not have to look. They could catch it all peripherally, and if everything was green on their numbers, everything was fine. As it started to go orange or yellow, it would change pages and bring up more detailed information, and they never had to push anything, and they were just being fed back a little bit of a visual difference, and that makes all the difference in the world to being able to concentrate on your driving.
Absolutely. Yeah, the more you can just
automate,
glance and understand information, the better it's going to be. You don't have to wait for a straight line to look down and process digital values, which is everything looking good? Or
exactly. Okay. Where else? Is there anything else you wanted to go with the live presentation materials?
I think we've pretty much wrapped it up. Unless anybody wants to. There's some, I don't know if you guys noticed, but the new display pages, I'm personally a huge fan of the new display pages. They have a wonderful look and feel to them, RPM sweeper, speed.
Which hardware are they available on? Anything that's TFT?
Not quite yet. This would be the wheel exclusive.
Okay.
This display right here, the last I checked, we had a software released this morning. And this page was available for most people, most TFT screens, 1.2 generation. So here I actually have, I don't know if you guys caught this right here, but these are 2 bar growth formats where you can set basically a 0-100 indicator here, and I've optioned to put my lambda control here and my battery voltage here. So if I'm worried about battery voltage dwindling, it's not a numerical number that I'm looking at. I'm actually just looking if it's in the red. Lambda value, basically that 14.7 should be somewhere right in here. I would want to be at the halfway point, and if it's too rich or too lean and I'm under full throttle, that's a good indication for me, a visual display.
Always good for different people that like to look at things in different ways. If we just give the options, some people won't like that, some people will love it, and it's just, I think it's great to have the option.
Yeah, I really love the new artwork,
Yeah.
the new art profiles, the direction that we've gone. They do look clean, and for me the small lettering is
Yeah.
awesome.
In the black background, again, it helps with that color change of the channels as things change.
Yep.
So,
So I think
okay.
that I'm pretty much ready to kick it over to you. But I did see some stuff in the chat. Kyle was wondering price points and availability. So I'll go ahead and stop my sharing there, Roger. Sorry.
Okay, go ahead
Click the
and
button.
answer any of the stuff in the chat as I kind of change things around here.
So pricing, availability. The availability is that it's available. We're ready for you. Get your orders in, and we'll be happy to get you taken care of. For dealers and inquiring minds, just give us a call. There are a lot of different packages that can be used. So we have the 320 wheel with paddles, the 320 wheel with paddles and car side harness, and you can just extrapolate from there that we have that for each one of the systems. No, John, no newer dashes for the Evo 4S at this point. So we still have the Formula steering wheel. We still have the GS dash.
Mike James
And
mentions there in a note that there are a number of dozens of new TFT pages that are designed and just waiting for some firmware updates to make those available. So you'll be able to see some new ones coming up very soon. It looks like.
yeah, and they look good. They look really good. Um, the the paddle shifts are bought a la carte. So they come in a package. If you want the paddle shifts or the clutch paddles, you would option to add those to an existing wheel, or you can purchase the wheel with the paddles already installed and ready to go. So it's just one of the packages you could do.
Perfect. I think it's been a great primer about the steering wheel for a new product for us, but it's integrating a lot of the same stuff that we know about other things, but just giving it even more power and putting it in a great package with the 4 different sizes. We will see them in all the way from small formula cars with the small one to fire breathing off-road race trucks, right? For the larger ones, and everything in between, production based cars, whatever. It looks like a very fantastic piece of hardware to me.
Yeah,
So
and my goal with this was just to show um, the aptitude of this steering wheel. It has such a complex nature. Some people might think it's overwhelming, but I think the software team has done an amazing job making the tools easy to understand, easily read by someone who maybe doesn't do this for a living. Like sometimes I forget, not everybody has the opportunity to play with racing electronics every day, every hour of every day.
Matt also mentions that the wheel has a great feel to it. It's designed well around the handholds and the size, so that's good to hear as well. Okay, just as soon as we get finished up, of course, this video, along with all the rest of them, will be added to our Learn Fast e-training video site, YouTube, and it'll be number 179 that'll be up there. So take a look back at it. We went over a lot of information fairly quickly, always by design. That we try to get as much information in here as we can, and then it's hopeful that we get the folks to go back and Robbie talked about when he was talking about that one fuel pump out. I'd like to see how he did that. Go back into the video and take a look at it and get a little bit see some of the detail that he did there. So they'll always be up there. I work as fast as I can to get them up within an hour or so. So the customer support, boy, it's been a busy number of weeks for a lot of racers in the road racing side, at least, certainly, and for our tech support guys. We've had national events we've all been to and around. So if we haven't ran into you, and I know we've run into a lot of folks, if you still haven't caught us at the track or need anything during the winter, and give us a call with the 800 number there. We're happy to help you get all your questions answered and get everything up and running and ready for the winter season or next spring. So give us a holler. What are we going to do next week? We're gonna have a host that we've had any number of times. Peter Krause, always always folks just love chatting with him and listening to some of the stuff that he adds to these. And Peter's going to come in and talk about something that he's been chatting with a lot of different people about, but how to overcome the hardest part of going faster. There's some specific areas on the track and specific things that you do as a driver that are that he wants to focus in on and give some solutions. Not only give some perspective and show what it looks like in the data, but then how to read the data and how to overcome that as a driver to get past those typically the turn in and the throttle on coming off the corner, those hardest parts of going faster, how to overcome that, how to recognize it, and then use data to overcome that data and video. So Peter's going to join us a week from today on October 12th. We're going to have a good time with that. Everybody is always excited when Peter comes on. He gets all excited and starts talking fast. So it's fun to chat with Peter. He truly loves data and coaching drivers. So we'll have Peter here with us again next week. Looking forward to that. Oops, a little bit of contact information. We went through a lot. Robbie's always helpful to chat about different things. There's his email address. Give him drop him a note and ask him about some of the detail that we just chatted about. Of course, there's my email address, Roger at AiM Sports. Drop me a note if there's anything that I can do to help as well. Thanks everybody for coming. It has been this was a great one. And we don't do a ton on hardware, some of the AiM products, but this is a special one, new, and I thought everybody would really enjoy it. I had gotten 5 or 6 different notes from folks saying, boy, I see this new steering wheel. I don't know anything about it. Can you chat about it? So here we have done it, and Robbie has done such a fantastic job. Anything else you would like to add, Robbie, as we're kind of closing this one down?
Thank you for the opportunity. I always love coming on here and chit-chatting with you about electronics and the racing environment. And it's always a lot of fun. So I just appreciate you having me on.
No problem whatsoever. We'll schedule Robbie in again in the future. It's always I always love having him on here. He's such a smart guy and understands this stuff so well. So thanks everybody for coming. I look forward to seeing everybody here a week from today, next Tuesday with Peter. Everybody have a safe week, and if you're going to go to the racetrack this weekend, have a great time. And we will see you here next Tuesday. Talk to you guys soon.